So we're going to finish up doing the other half of the quadratic formula here, so part 2. If you recall, last time we talked about quadratic formula. Does anybody remember what it was off the top of their head without looking at the board? Can anybody recall it? You got it, Garrett?
X equals negative b square root of b squared minus 4ac over 2.
Nice job. I forgot one detail, not the plus or minus, but that is correct, actually. So we're going to use that same exact formula today. The only difference is now we might not get real solutions. We actually might get complex solutions. Okay, so we're going to use the same exact formula here, as Garrett just said. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And really, what does this all come from? It comes from finding these zeros. So if you think about my graph here, if I were to have a parabola, I'm finding basically where it's 0 at. So where are the maybe like starting and ending points? If I were to throw a ball from here, where would it land? All those different type of projections that we're doing with it. Okay. Here was what we looked at last time. So very detailed review. The key is whenever we set these, we always want to set them equal to 0. So remember we solve these, set them equal to 0. We identify what A, B, and C are. So A equals 1, B equals negative 6, C equals negative 11. And then I plug in and I solve. Now what's nice about these complex solutions is there's only so much I can simplify. Because I'm going to get an I in a lot of these solutions, I can't add and subtract everything and get an actual answer of like 2 or 3 or negative 1. I'm going to be left with something more like this answer right here. Or possibly maybe more like this answer down here. I can't simplify everything all the way down like we had to last time. So that's kind of nice about these. Let's do a little review of number 1 here. Okay, so this is review of what we did with the first half of the quadratic formula. So 2x squared plus 3x minus 5. What would A equal in this quadratic? What's A going to equal, Colin? A equals? 2. B equals what, Colin? 3. And C equals what, Colin? Negative 5. So when I look at my formula, I'm going to plug that in, giving me negative 3 plus or minus the square root of 3 squared minus 4 times 2 times 5 all over 2 times 2. Okay. Oh, that is negative 5. You're right. Good work. Good catch. Negative 5. Thank you. So I plug that in, and then I simplify, giving me negative 3 plus or minus the square root of 9 plus 40 all over 4, which is really negative 3 plus or minus the square root of 49 over 4. And what's the square root of 49 then, John? 7. So I get negative 3 plus or minus 7 all over 4. Now here's where, remember, this is kind of unique. I can get my 2 solutions. I do the plus and I do the minus part of solutions. So if I go negative 3 plus 7, I get 4 over 4, which actually is x equals 1. And then I go negative 3 minus 7, which is negative 10 over 4, which actually gets me then negative 2.5. So that's where I get my 2 unique solutions. All right, we recall doing this last time? Good. Try number 2 on your own. Take a couple seconds, try number 2 on your own. Same type of problem, you're going to have to simplify. So as you work through this one, hopefully identified, A equals 6, B equals 5, C equals negative 4. When you worked it out then, you ended up with negative 5 plus or minus the square root of 121 all over what would have been 12. Now what's unique? What's square root of 121, Sean? What square root what? 11. So I get negative 5 plus or minus 11 all over 12. And now I can get my 2 unique solutions. What would those 2 unique solutions actually be? Phil, do you have them both? What's negative 5 plus 11? So 6 over 12 gets me 1/2. And then go negative 5 minus 11, which gets me negative 16 over 12, which is actually negative 4/3. Okay? So again, toughest part about some of these problems is we actually simplify them down with those plus or minus. Now we get into what we're going to do today, which is, well, what happens when we actually get a complex or imaginary solution? So number one, I want to find the zeros by using the quadratic formula. Same exact formula, doing the same exact work. The only difference is we're actually not going to have to simplify as much. So what would A equal here, John? A equals 2. B equals what, Bailey? Negative 1. And C equals, Andy? 2. Okay, so I identify A, B, and C, and now I plug it in quadratic formula. I get a positive 1. Does everybody agree with that? The two negatives out front give me a positive 1. Plus or minus square root negative 1 squared minus 4 times 2 times 2 all over 2 times 2. So again, looking at this here, doing the same exact work I did, plug in A in for my A parts, B in for B, C in for 2. And now I simplify. So I'm doing the same exact work, same exact formula. Now I'm going to simplify here. So I get 1 plus or minus the square root of 1 minus 4 times 2 times 2, Bailey? 16, good job. All over 4. Now what do you notice right here as you look at this? What are you noticing here, Colin? What's going to happen underneath my radical? When I simplify that, what do I get? What's 1 minus 16? Negative 15. Yeah, what happens here is I get 1 plus or minus the square root of a negative 15 all over 4. When I simplify, can I have that negative in there, Sean? No. What's going to happen when I simplify that? What's going to come out of it? I. So what actually happens here is I get rid of that negative by pulling the I, that imaginary part, out, getting me 1 plus or minus I square root of 15 all over 4. And then I look from here. Can I simplify that farther? No, there's no other fractions. 15 doesn't break down with it. That's actually my answer on this one right here. So what's nice about these problems is I don't have to simplify them further because I can't. I can't combine my imaginary parts with my real parts. So I get my complex solutions. All right? Try number 2. Take a couple seconds to try this one. Same type of problem. We're going to get an imaginary type. All right, let's start walking through this here. What do you have for A, B, and C, Reagan?
4, 3, and 2.
A equals 4, B equals 3, C equals 2. When you plug it in, then what did you get? Should have gotten, was it negative 3 plus or minus the square root of, is it negative 23? All over 8?
Yeah.
When you simplify it down, is that right? And then what's your final answer going to be, Phil? No, we can do one more thing yet. What can we do with that negative?
So it'd be 3 plus or minus I
All over 8. Nice job. That is exactly what your final answer would be. If the last thing you have to do is just get rid of that negative inside the radical, pulling it out, making it that imaginary part. All right? Do we agree this is almost a little bit easier than what we did the other day? Why? Because we don't have to simplify it as far. It's a lot easier when we don't have to do those simplifications. All right? Last thing we're going to talk about today is what is the discriminant. All right? So the discriminant of ax squared plus bx plus c, so that standard form, is the part b squared minus 4ac. Now that should look familiar to you. Why does b squared minus 4ac look familiar to you? Bailey, why does that look familiar? So it's the what? You're right.
Like the part in
Yeah, that's the part right here in the quadratic formula. This is the part that's underneath the radical. So if I look just at what's underneath the radical, I can determine whether I get real solutions or complex solutions. That's what's called the discriminant. So as I look through here, if I get something that's greater than 0. So for instance, if I get like a number 49, this is what we're doing on Friday. If you get something like that, then I'm going to get two real solutions. Because what happens here is my number underneath the radical will be positive. I can get two real answers. If I get 0 under there, that's when I get one real solution. Okay, I get one real solution because if I get 0 here, that eliminates, giving me just negative b over 2a, which is then my vertex actually. And then if I get a negative underneath my radical, that's where I get two complex solutions. And why is it complex solutions? Because the negative underneath here would be that imaginary part, give me two complex solutions. So I can look at this discriminant to identify whether I have two real solutions, one real solution, or actually what would be two complex solutions. Okay. So again, yeah, that looks familiar. We're really doing about half of the quadratic formula here, and we can identify what it is. So number 3 here, let's go step by step through this. Anytime we want to set these up, we always want to set them equal to, John? 0. Anytime we set them up, we always want to set them equal to 0. So recognize they added 36 to the other side, set it equal to 0. Identify A, B, and C. What's A, B, C going to be, Jarrett?
1, negative 12, and 36.
Awesome. And now I plug it into that discriminant part, that part underneath the radical. So I get negative 12 squared minus 4 times 1 times 36. So I plugged it into that discriminant part. Negative 12 squared gets me, Sean? 144. Minus 4 times 1 times 36 gets me, Garrett? It's all right.
144.
It actually gets me 144. So 144 minus 144, what's that going to get me now? 0, which means I have one solution. Okay? So I'm looking for what that discriminant is, and if it's 0, that means I'm going to get one solution. You all right, sir? You all right?
Yeah.
Good. Didn't lose everything, did you?
No.
Good thing your iPad wasn't out right there. That's good. Number 4. X squared minus 4x equals negative 7. When I set these up, I want to set them equal to what, Shane? 0. So I'm going to add 7, giving me x squared minus 4x plus 7 equals 0. I identify my parts. What are A, B, and C, Colin? A equals?
1,
B equals?
negative 4,
And C equals?
7.
Nice job. Plug that into my discriminant, giving me negative 4 squared minus 4 times 1 times 7. Negative 4 squared gets me, Andy? 16. 4 times 1 times 7 gets me what, Andy? Negative 28. So I end up with 16 minus 28 gets me what, Andy? So that means that part underneath my radical would be a negative 12, giving me what type of solutions, Andy? That gives me two complex solutions. Nice job. And let's go to number 5. X squared minus 7x equals negative 3. Whenever I set them up, I always want to set them equal to what, Bailey? 0. So I get x squared minus 7x plus 3 equals 0. A, B, and C equal what, John?
A is 1, B is negative 7, and C is 3.
Good job. Plug that into my discriminant. Gets me negative 7 squared minus 4 times 1 times 3. Negative 7 squared is going to give me what, Jarrett?
49.
49. Minus 4 times 1 times 3.
Negative 12.
And that gets me 37. Ooh, that's bad 7. So 37, which means my answer then, how many solutions do I actually get here? Jarrett?
1, 2.
2, what type of solutions? If it's positive, it's going to be
That's your symbol?
what?
I don't know.
So if I get negative, I get complex solutions. Because if I have negative underneath here, that's where I get my complex. So if it's positive, I'm going to get 2 then. If it's not imaginary, it's real. So if I get positive, that's where I get my 2 real solutions.
So if they're negative, it's always complex.
Correct. Yep. Whenever it's a negative under there, it's always going to be complex because you got to think about that radical. If I get negative, can't have that negative. That's where I get my imaginary number, which is then the complex solutions. Nice job, sir. Yes.
Would 0 be the only time you get 1?
0 would be the only exact time you would ever get 1. And what happens when we get 0 is I lose my plus or minus then. So I'm left with just negative b over 2a, which is just one unique answer then. It's a great question. Right. Take a couple seconds, try these next 3. And again, remember, with all of them, you always want to set them equal to 0. All right, let's start walking through these. Reagan, when you simplify it all down, what do you get for your discriminant on number 6? What do you get for your discriminant? B squared minus 4ac, what do you get when you simplify it? 8. Nice job, because you'd get 36 minus 28, which then means my answer is what, Reagan? 2 real solutions. Nice job. What about number 7? Phil, what happens when you simplify number 7 all the way down?
0.
Yeah, you actually get 0. I think when you work it out, you get 36 minus 36, which is 0, which then means my answer is what?
1
Real solution. 1 real. Yep. The only time I'll get complex is when I actually get the negative. That's the only time I would ever get complex. Thank you. And then number 8. Colin, what'd you get when you simplified it down? What do you get? You do get negative 8. I think you get 36 minus 44, right? Which then gives me what? 2 complex solutions.
The reason they're all negative such that
It's basically the same problem. They just changed up the constants. Just to show you the difference in it. Nice job. Here is your assignment.